This is section 4.2, number 47. So they're asking for relative max and relative mins. And everybody knows relative max and relative mins can only occur at critical points. So we are going to find critical points. So f prime of x, I'm going to rewrite this first because I don't like the square root. I'm going to rewrite it without the square root. X to the 1/2 ln of x. We see a product, so when we take the derivative, it's going to be product rule. You leave the first alone, take the derivative of the second, plus we take the derivative of the first and leave the second alone. We're going to factor. Actually, you know what? Wow, this is really cool. I'm going to rewrite this. This becomes x to the 1/2 minus 1 plus 1/2 x to the minus 1/2 ln of x. I don't know if you saw what happened. We're dividing two exponents with the same base. You subtract exponents. So it's going to be 1/2 minus 1. Why is that so beautiful? Because this is x to the negative 1/2, x to the negative 1/2 ln of x. So I'm going to factor out a common factor. I'm going to factor out 1/2 x to the negative 1/2. So I'm taking out, they both have that. They both have that, and then there's a 2 there. You're going to say, that doesn't have a 2. Yes, it does, right there. Okay, so what's left? Well, if I take out that 2 and that, I'm left with a 2. If I take out all of that, I'm left with ln of x. Whoops, I forgot my plus sign. Plus ln of x. Now rewriting this whole thing, I get 2 plus ln of x all over 2 radical x. Okay, so that is my derivative. How do I find my critical points when I have a fraction? Well, when the numerator is 0, I have a critical point, and when the denominator is 0. So I set the numerator equal to 0, subtract 2 from both sides. Now, you need to be comfortable working with ln's. How do you get rid of an ln? E is the inverse function of the ln. Those will cancel, giving me x equals e to the negative 2, which is 1 over e squared. So that is one critical point. Now, if you set the denominator equal to 0, x equals 0. Is that a critical point? I say no. Why am I saying no? Because that's not even in domain. 0 is not included. So we only have one critical point, 1 over e squared. So I'm going to make my table, like I always do, to figure out if that's a relative max or min. This is 0, and that's infinity. And this will be, my brain's not working, x. And we want to know what the derivative is, because the derivative tells us increasing and decreasing, right? So this is a beautiful problem. What's the number between 0 and 1 over e squared? I claim 1 over e cubed, which is e to the negative 3. Wow, you can't see that, can you? That's a weird number, Yoshida. Yep. Yes, sir. And then what's bigger than 1 over e squared? 1. 1. Let's plug that into the derivative. So if I plug 1 over e cubed here, that's positive. Square root of a positive number is positive. If I put e to the negative 3 here, ln and e cancel, giving me negative 3. 2 minus 3 is negative 1. That's negative. Right? Then I'm going to plug 1 in. ln of 1 is 0. So that's positive 2 over 2. That's positive. So mentally, I'm like, oh, it's decreasing here and it's increasing here. Forever. To the right, it's increasing. clearly, at this point, I have a relative min. So I state f of x has a relative min at x equal 1 over e squared. And why? We have to give a reason. Because the derivative of f does what? It changes from negative to positive at x equal 1 over e squared. Bam! That's my relative max or min problem with justification. And one more part. They want the absolute max or min. Now, this is a special theorem that we had that was in the video. Now, if you have a continuous function with only one critical point, that critical point, if it's a relative max, will be the absolute max. If it's a relative min, will be an absolute min. Here's why. Look at this function. From 0 to 1 over e squared, it's always decreasing. And to the right of that, it's always increasing. Well, clearly that's an absolute minimum. Has to be. Because there can't be a lower point. To be a lower point, this would have to move down, but it can't because it's always increasing. That's a theorem. So if you have a continuous function with one relative max, then it's an absolute max. So we can say the absolute min, sorry. The absolute min is f at 1 over e squared. I can figure that out if I put that in the original function. Oh, I can do that. Which is square root 1 over e squared times ln e, oh, e to the negative 2, which is 1 over e, and that's going to be times negative 2. That's so cool. There is our absolute minimum value for this problem.